Good morning, welcome back. So today we will discuss about the BERT model, a sample use case of how we can use the BERT for NLP analysis and some various types of BERT models. As the name itself, the BERT is bidirectional encoder representation from transformers. In the earlier sessions, we have seen various word embedding models as word2vec, next fastest, next Glowy, and also we have seen a light introduction on BERT models. Today we will discuss about the architecture, the components of BERT model, and how we can use the BERT for the NER application, name entity recognition, for a small case study, and then we'll see the types of BERT models. As we can see in this diagram, we have the BERT model which is being processed and which is being mapped to the word embeddings from the input text. From the raw text what we give, it is being tokenized in the usage of word piece tokenization. Here the embedding layer is formed, and then we have the multi-layer transformers which is being stacked in terms of 12 or 6 layers. Next we have a bidirectional encoding, next masked language model, next followed by pre-train. Then we can have the application of fine tuning based on the requirement of how our raw text input is, and then it forms the embeddings, and then we can illustrate with the output. So coming to the detail part, the first one as the word piece tokenization. How does this does? It breaks the words into small sub-word units and tries to make into some masked kind of output. Like suppose I have the word unhappiness. So for that you have the tokens as next happy which is being masked pre and post. Next for happiness it is being considered like this, where this indicates a continuation for the previous token. So likewise it is being mapped with the previous occurrence of the term as well as the next term. If I have suppose machine also, next I have MA as one, next masked by CH, next I have again masked by NE, and so on. Next, this word piece tokenizer will again give the input to the bidirectional encoder. So this will process the text bidirectionally. Bidirectionally means from left to right and from right to left, which considers both sides and tries to provide more comprehensive understanding for word meaning in the context, where you can get more illustrative meaning of that particular word. So these transformers will now use some self-attention mechanism that will allow the birds to focus on the relevant words when processing a particular token. So on unhappiness, on ness, on unhappy. Likewise, it will allow us to focus on those things. This masked language model, after this training phase and all, will mask some words in the input and tries to predict that based on the surrounding context. Now, where this word unhappiness has been used, if it is in terms of giving the reviews to the movies or in terms of the live series or live discussions and all. So this strategy of masked language modeling will help BERT to develop the deep understanding of the language relationships. How the similar, are there any similar terms with unhappy? Yes, idle state. Yes, after this pre-training of this BERT model, then we can fine tune for some specific application, or we can use it till here. This approach allows the BERT to adapt to more general language understanding to other specialized applications. So we could see here we have a embedding plus vocabulary, then applying the softmax application for each vector of the words. We also have a classification layer where I can classify and then apply some normalization or apply some softmax applications and then do it. Next, we also have transformers which performs the encoder and decoder. We have the embedding layer here at the top as well as at the bottom. Next, this is how these transformers will work in both the directions. So as we have mentioned, let us see a small example where I can use the BERT model to illustrate the NER. Yes, the name entity recognition. I have a sentence called as Rahul works at Google in Hyderabad. There is a sentence. Actually, in the NER, we are supposed to illustrate the output as where the Rahul is a person and he works, it's a verb, and he works in Google company, which is an organization, and that company lives in Hyderabad. So, for this input sentence, this is how the BERT tokenization splits into words. One is Rahul works at Google. This is how it is being marked here. Next, for the location, it is being marked in this thing. So, after that, for each word Rahul, a dense vector is being represented for Google separately. Now it has been marked GLE separate, Go as separate GOO. Yes, so this will produce this context aware embeddings like this. These vectors understand not only the just the words but also the context where this Rahul or where this being used. Yes. So for this sentence, Rahul works at Hyderabad and all. For this, it is being mapped with some predicted label as this stands for the person. Similarly, this is for the objective and all verb. Next, we have the Google company, which is an organization. Even this is also being treated as an organization. Next, Hyderabad, which is being again represented as a location. This is how is being used with the BERT model. Similarly, you also have an input sentence. Patient John was diagnosed with diabetes and prescribed metformin at Apollo Hospital. So, we have the illustration where we need to extract about the John person. Yes, about the diabetes which he has been diagnosed. Next, the tablet what he has used and where he has been taken all this at which organization. For that, if we could import this biomedical BERT model directly, and by importing the transformers, installing the transformers, and then we can importing the pipeline directly, and then if we give a sample text like this, if we could see that after doing the entities and all, we can see that for the entities are being displayed like this. For the diabetes, which is being labeled as a disorder, and for metformin, which is being labeled as the medication, which is being done automatically. Of course, few of them you can also do it accordingly. This is how the BERT models we can all directly take it from the Hugging Face and all. So there are some likewise we can also use and apply the BERT models for the detailed application process also. Let us see the some variations of BERT models where we have Roberta as a specified one, which is used for optimized training applications and it is having with improved performance. We can also have distilled BERT, which is faster, smaller when compared to the normal BERT model. Based on the attention and distangle purpose, we also have decoding enhanced BERT model. If we talk in terms of domain specific, we have BioBERT model, biomedical text pre-processing. Next, for finance applications, we have separately as FinBERT. For legal document applications, we have LegalBERT. For clinical training and to do the doctor notes and medical test, we have clinical BERT. For performing the factorized embeddings in terms of good parameter efficient, we have Albert. These models we can use in our own customizable data applications based upon my need or my requirement. I can use it accordingly. Next, we also have for multilingual, where the famous one is MBERT, multilingual BERT model. For to perform the cross-lingual applications, we have XLMR. In all, also we have Distill MBERT. Yes, the size of the BERT may vary based on the model, and also the fine tuning may also change based upon how the raw text is being used and all. Some may have 768 dimensional embeddings, some may use of 12 layered, some may have 1000 plus, some may have more than that as well as, but it also depends upon the usage of this. So in the next sessions, today to wrap it up, we have discussed about the components of BERT model, how it is being used for NER, some types of BERT models and how we are going to use it for the various applications. In the next session, we'll be discussing about text classification, what are its types, and some small example. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.